Hello everyone. In this slide, we are going to describe various methods of doing software testing, and we will going to describe what is software testing and its various types. So firstly, we are having some objectives of testing. What is the testing? Testing is a process of executing a program with the intent of finding an error. It means that if we say what is testing, that many people understand the definition of testing as it is the process of demonstrating the errors are not present. That means we have to show the absence of errors, but it is not actually that. The purpose of testing is to show that a program performs its intended function correctly, which is again an incorrect definition. Testing is the process of establishing confidence that a program does what it is supposed to do, but it may produce the result other than that also. So a more appropriate definition is the testing is the process of executing a program with the intent of finding an errors. So a good test case is one that has high probability of finding an as yet undiscovered error. That means we have some undiscovered errors that may be possible in a software, and we have to find one all of these type of defects through a good test case. So then next is a successful test is one that uncovers an as yet undiscovered error. That means we have to develop some test cases as per its process that may uncover the defects that has not been visible to us. So we are having very basic terminologies associated with the software testing. First is the error. The error, people make errors. So people make errors. It may be type of any type of mistakes. Mistake is a good synonym of errors. Errors or mistake made while coding is called bugs. Obviously, a developer or a coder may produce different type of bugs that may be reflected in the form of code. So errors may be of typographical error. That means we are having some typing errors. Next is misreading of specification. Specification is what? We are having software requirement specification. So we may misread them. Okay. Now third one is misunderstanding of functionality of a module. That means we can understand a module like it's performing something different, and in actual we have understood it in a different way. So next basic terminology we are having is fault. Fault or defect is the product anomaly. That means product is not performing its intended function. A fault is the representation of an error, where representation is the mode of an expression. Representation means we are representing something. So we are having representation as narrative text. That means while narrating it, we are having some text and we have described it something wrongly. We are having data flow diagram that shows basically flow of data. And if we describe the flow of data in a wrong way, then obviously it may create some fault. Now next is hierarchy charts. Hierarchy chart means we are having one class derived from any other class, and the third class is derived from the first class. It may be we may have different type of hierarchies. It may be multiple, it may be multi-level, it may be hierarchical, or as something different. So it may have some fault in that also. We are having some source code, and so on. We may have different type of faults. Source code also inherits some faults. Usually, faults are undiscovered after the software has been released to the end user. So a user may find out some errors in the form of faults. Now next for this is we are having failure. Failure is a non-conformance to software requirements. That means software requirements are not completely fulfilled. That means we are non-conforming them. A failure occurs when a fault executes. So a fault will execute if a fault will be executed, then obviously a failure will occur. A particular fault may cause different failures. It may crash the system depending on how it has been exercised, as it depends on the fault that what type of fault we are going to execute in the system. So we are having some principles of testing, that is all tests should be traceable to customer requirements. That means all tests, whatever we are going to design, whatever we are going to test, that should be traceable to customer requirements, as obviously customer requirements should be fulfilled and it has to be checked. Tests should be planned long before testing begins. It doesn't mean that testing should be carried out after the development phase. It should be planned before the testing begins. So we have to develop test cases as per the test case requirements. The Pareto principle applies to software testing. Pareto principle states that we are having 80% of the defects due to 20% of the outcomes. Outcomes basically from the 20% of the code. So main region of 20% supplies 80% of the defects. So we have to find out that 20% region. So testing should begin in the small and progress toward testing in the large. In the small means that we have to perform initially as a component level testing, and then we have to move to the in the large. That means we have to perform the complete system testing. Now next is exhaustive testing is not possible. Now exhaustive testing is what? Exhaustive testing means we have changed some code, and on the basis of that code there will be a big changes. So exhaustive testing means we have to test the complete code. That is not possible. So to be most effective, testing should be conducted by independently third party. If we test our own code, if we test our colleague, if we test our team member, then it may be difficult to find out some errors or defects. So it will be most effective if we will check through the independent third party. Now next is attributes of a good test. So high probability of finding an error. A good test case should have a high probability to find the errors. No redundancy should be there. That means the duplicate test cases should not be there. Best of the breed. That means in its generation it should have the best result. So it is called best of breed. Neither too simple nor too complex. It should not be too simple that it can be easily generated, and it should not be too much complex that it cannot be evaluated. So we have to perform testing in like that way. Test, test cases and test suits are something having some relation. So test and test case terms are used interchangeably. That means we are going to test something through the test cases. In practice, both are same and are treated as synonyms. That's why we are saying that testing means we are having some test cases. Test case describes an input description and an expected output description as per shown in the diagram, that we are having section 1 before execution, purpose, precondition, inputs, expected outputs, post conditions, written by means that test case has been written by some person, its name, date, and after that after execution. That means we are having test cases before execution, that is planned, and after execution, that is actual, that is execution history. Result, what is the result of that doing testing, that is test case is pass or fail. If fails, then possible reason, any other observation if a tester has found, any suggestion or run by, and date. So the set of test cases is called a test suite. If we are having a different type of test cases for a particular feature, then it means called a test suite. Hence, any combination of test cases may generate a test suite. So under the software testing again, we are having verification and validation. So verification is the process of evaluating a system or component to determine whether the products of a given component given development phase satisfy the conditions imposed at the start of the phase. That means in the verification we are going to test the conditions, we are going to test the process that we are going to use for generating a particular software or a product. Validation. Now validation is the process of evaluating a system or component during or at the end of development process to determine whether it satisfies the specified requirements. That means we are going to actually execute the system under the validation to test that it is actually giving the same performance or not. So testing means valid verification plus validation. We are having different type of testing: alpha testing, beta testing, and acceptance testing. First, describing the acceptance testing. Acceptance testing is used when the software is developed for a specific customer. That means a customer has some requirements, and according to those requirements, we are generating a test for a particular software for a particular customer. So a series of tests are conducted to enable the customer to validate all requirements. That means a user will test that my requirements are going to be fulfilled by this software or not. These tests are conducted by the end user or customer and may range from ad hoc tests to well-planned systematic series of tests. That means a user may have their own test cases, or it may be developed through the company. The terms alpha and beta testing are used when the software is developed as a product for anonymous customers. That means a product is available in the general market to be purchased by anonymous type of customers. Then we are having alpha testing as well as beta testing. So alpha test. Alpha tests are conducted at the developer site by some potential customers. They may be developers. So they are having some technical sound knowledge. So alpha testing is conducted at the developer site, while the beta testing are conducted by the customers or the end users at their sites. then it means beta testing may be conducted by the customers themselves. So they may be technical, they may not be technical. Unlike alpha testing, developer is not present here. Beta testing is conducted in a real environment that cannot be controlled by the developer. So we are having a functional testing. Functional testing suggests that we are having input test data, system under test, and after that output domain. That means after performing some black box testing means functional testing. Functional testing, we are performing the test through the input domain, and that is converted into the. Now under the boundary value analysis, that is the functional testing, we are going to analyze a problem where we are having two input variables x and y. These input variables have specified boundaries as a to b and c to d. We are having two variables x and y. Those range varies from a to b and c to d. If we show it through the diagram, that means we are having a, this one is your x, this one from this to this place, this is your x, and it varies from a to b. And same way we are having y, and it varies from c to d. That means is it, this box is representing the boundary for the x and y value. So next, the boundary value analysis test case for our program with two input variables x and y that may have any value from 100 to 300. Are this one 200 to 100? Obviously 200. These dots are showing the boundary values, boundary value test cases for this particular problem. So we are having 200, and then obviously if you are having 200, then starting 100. After that 200, and then 101. That means is slightly upper than the boundary, that is 101. Now after this we are having 200 and 200, that means middle one. Now next 200 and 299, this one. Okay, now after that 200 and 300, this one. Now after this we are having 100, we are moving to the next boundary 100, and then 200. Now next 101 and 200. Now next again leaving the middle one as we have covered it already. So now 299 and 200. Now next is 300 and 200. That means we are having a program of n variables, and then boundary value analysis will be 4n plus 1 test cases. So for this particular problem we are having a equation example. So if we are having quadratic equation problem solution, we are having obviously the solution says note a quadratic equation, real roots, imaginary roots, equal roots. Then we have to design a boundary value analysis for this problem. So quadratic equation will be this one. Now we are having the general equation says roots are equal, real, imaginary. Quadratic equation will be yes or not possible. So if a is equal to 0, we are having different type of boundary value test cases for particular values like 0, 50, 50. We are having three variables. So after these three variables, we are having expected output as not quadratic. For this problem 150, 50, that is real roots. All of these test cases have been generated through boundary value analysis, as we are having three variables. So if we are considering the formula, that was 4n plus 1, going back to the this one 4n plus 1, that means we are having three variables, and for the three variables we should have 4 into 3 plus 1, that means 13 test cases. So 13 test cases has been generated for this particular problem. Now this problem describes the boundary value analysis for a simple example of quadratic equation problem. So after solving or after seeing this problem, a person or a student can do the boundary value analysis or boundary value test case generation for a particular problem.